Hello and welcome to Social Studies 3201, Unit 4, Population Issues. Today we will look at Outcome 10.2, Explain the Theory of Demographic Transition. In the previous section, we've seen how technology and science and new developments can affect Earth's carrying capacity, or the number of people who can be supported on the Earth's resources. In this outcome, we will look at how populations change, not just why. So we have a couple of key terms we'll look at first, which we'll explore as we go through this section. First off, demographers is a term that you'll sometimes see used to refer to people who study population. The point is that population change is not random, but can in fact be predicted. And that's the basis of what we will look at today. And in order to predict what's happening or what will happen with a population, we look at a few key pieces of information. And in particular, we'll look at birth rates and death rates. The birth rate is the number of births in a country for every 1,000 people in the population. And the death rate is the number of deaths in a country for every 1,000 people in the population. We use a rate to describe population change based on births and deaths because you can't use an absolute number. A country with a very small population may have a certain number of deaths that for that country might be considerably high. But for another country with a very large population, that same number of deaths would be quite low. So a rate is a standard number that helps us compare conditions between countries in terms of population change. So how do birth rates and death rates connect with population increase or decrease? From our visuals here, we can see clearly that if the birth rate is greater than the death rate, then you will have a population increase. There's more births are occurring at a higher rate than deaths. So naturally, population will increase. Steady population or stable population will occur when birth and death rate are about the same. So as population increases, it's decreasing by about the same as well. And finally, a population decrease occurs when there's a greater death rate. Okay, and this will describe three basic situations that a country might find itself in. And we'll explore these in much greater detail as we go through this section. So when we want to find out how quickly a population is changing because of these factors, birth rate and death rate, we will consider those natural factors. We will often take the birth rate and subtract the death rate, which is really what we're doing in these visuals above. And what that'll do is it'll give us a number called the RNC, or the rate of natural change. And the rate of natural change can be positive or it can be negative, and it can be higher or lower depending on the situation. So let's look at a very quick example. Let's say a country has a birth rate of 9.3 and it has a death rate of 7.4. So if you plug that into our simple formula, you'll get 9.3 subtract 7.4, which will give you 1.9. So that means that the RNI, or what we call the rate of natural increase, which is derived from the rate of natural change, the RNI of 1.9 represents the population increasing at a rate of 1.9 people for every 1,000. Okay. You could also, depending on the situation, end up with a negative number. Okay, so if your birth rate was lower than your death rate, you would end up with a negative number, and that would actually result in a rate of natural decrease or a negative rate of natural increase. Whichever way you want to look at it, as long as we understand the basic concept here is fine. And these are numbers that are meant to indicate roughly how quickly population is increasing or decreasing in a given country or situation. So generally, countries with a rate of natural increase of over 2 are usually LEDCs or less economically developed. And countries for whom that number is less than 1 are usually more economically developed. These are just basic trends that we'll see as we go through this outcome. And the reason we see this happening in large part is due to globalization, which we've talked about earlier in this course. With more globalization experienced by MEDCs, that will usually result in a greater access to a variety of technologies and economic resources. And those technologies can help lower death rates, for example, and certainly have an impact on birth rates as well. So we'll see what happens to those as we go through this section. So how can changes in technological development affect birth and death rates? So this follows directly from that point just above. So we've got 3 visuals here, each representing some element of what we'll talk about in the coming section. So over here we've got some birth control. In the middle we have medical procedures or technologies, medical understanding, scientific discovery even. And over here we've got clean water, which might represent sanitation as well. So these are 3 hints, more or less, of some of the key points we'll see going through this outcome. So the model of population change that we will focus on here is one called the demographic transition model. Demographic transition seeks to describe how countries experience change in birth rates and death rates over time. In particular, it describes a pattern that many countries go through or experience as they become more globalized or more developed. So, for example, as a country may transition from an LEDC to an MEDC over time, we'll note that the birth rates and the death rates in that country tend to decline. Okay, so there's a number of things we have to look at as we try to describe exactly what's going on there. So there are 4 stages to demographic transition, and we will summarize each one and look at a couple of key points there. The first stage we call high stationary. The second stage, early expanding. Stage 3, late expanding, and stage 4, low stationary. So the key thing to look at here is the terms stationary and expanding. So usually when we see stationary, we see a situation that remains roughly the same, and expanding. In this case, when it comes to population, birth rates, and death rates, it'll show a growing of the population. Okay, so the transition we mean when we talk about demographic transition is a change from high birth and death rates to low birth and death rates. And very quickly, if we look at the graph on the right side here, we can see each of the stages that were just mentioned, 1, 2, 3, and 4. And you'll see here we have birth and death rates per 1,000. on the left of our graph, and we've got time on the bottom. And what we note here generally is a very sort of round number kind of thing. We see that the birth rates are indicated here by this black line, which we'll trace along here, okay? And death rates are this blue line, okay? So we'll notice here in stage 1, both of those lines, even though there's fluctuation from one to the other, a little bit higher, a little bit lower at times, they are more or less similar. And in terms of our rate of natural change, will more or less cancel out. So therefore, the actual population growth or change here would be very, very low, or what we might call stationary. Okay, the population remains roughly the same. The big thing we see happening in stage 2, while we might see that the birth rate continues to remain fairly high here, it's the death rate, this blue line, that takes a dive and falls dramatically. Okay, so in a situation where you have a high birth rate and a low death rate, that's going to leave you with far more births than deaths, which will lead to an increase in your population, which on this visual is indicated as a natural increase. Okay, so in stage 2, from what we're seeing in this graph, we can tell that a country's population will increase dramatically. As we move into stage 3, we'll note that the death rate continues to stay low and to some degree may continue to fall down, while the birth rate starts to experience a significant decline as well. So a low death rate and a lowering birth rate will mean that how quickly the population is increasing is starting to slow down. Okay. So that's the key point we can take from stage 3 here. And stage 4, we more or less end up with a situation similar to stage 1, where the birth rate and the death rate cancel out. Okay, we get a little natural decrease here, a little natural increase here, little natural decrease, and so on. So that will more or less keep the population stable or stationary. So what this model represents in broad terms is a stationary population that experiences high birth rates and death rates in stage 1. And eventually that changes to a stationary population in stage 4, where birth rates and death rates are low. And in both cases, birth rates and death rates are more or less equal to each other, resulting in the stationary status that we mentioned. So let's take a look at each of these stages in just a little bit more detail to see what's going on there. So if we look at stage 1, high stationary, this is characterized by a high birth rate and a high death rate, which results in a more or less stationary or stable population, as we've mentioned before. The graph on the side here and the graph that's used in your textbook as we go through this section will focus mostly on the example of Sweden, but they will compare it with Mexico. The reason Sweden is used here is that Sweden has a very long history of recording birth rates and death rates. So we can actually see the change that occurred in that country over a very long period of time. So in that sense, it's more or less used as a standard indicator of the process. So we're using the same type of information in this graph, birth rate and death rate up here on the side, year or time on the bottom. The black line is the birth rate, the blue line is the death rate, and we get natural increase and decrease occurring as well. So as we can see here, there is some wild fluctuation at times, but more or less you get peaks in death rates that are balanced out at other times with peaks in the birth rate. Okay, so that'll result more or less in a stable population. So this stage represents all countries in the world before the Industrial Revolution. You'll remember in the last outcome, we looked at population change and technology. We mentioned that before the Industrial Revolution, the world's population remained fairly low for a very long period of time, and change was very, very slow. Certainly, the population did increase over thousands of years, but at a very, very low rate. It's not till we get to the Industrial Revolution that we'll see some of those major changes. So stage one indicates countries before the Industrial Revolution. So the birth rate is high and relatively stable with some fluctuation, and the death rate is high, but tends to fluctuate somewhat due to a number of factors. They could be natural in terms of famine. Maybe there are climatic conditions that affect food production. Disease outbreak can certainly increase the death rate in a country. Also, human activities like war can affect the death rate, of course. And the population sometimes increases while sometimes it decreases, as we already mentioned. And that will overall produce, when you look at a span of time, as we have in this graph, being about 100 years, the population remains more or less the same. So as a kind of a side note here, before the Industrial Revolution, the human population of the Earth was less than 1 billion, and it took thousands of years to reach that point. We already know from what we looked at in outcome 10.1 that after the Industrial Revolution, that number, the billions of the world population, starts to increase quite a bit. So let's go on to stage two. So stage two is called early expanding. And this is the period when the population starts to increase, or we start to see a high population growth rate. So this is due to a high birth rate and a falling death rate. Okay, so if we look at our lines over in the graph here, we can see that the birth rate, it's going down a tiny bit here, but it's still relatively consistent in this time period. But we see the death rate fluctuating, but it's starting to go down to a greater degree than what the birth rate is. Okay, so that's going to certainly create a situation where there's more deaths than births, and therefore a population increase. So this stage two, early expanding, represents more economically developed countries during the Industrial Revolution. So we're talking about countries in Western Europe first, but then in North America as well at first, that start to experience changes with industrialization. And some of the key things that we see happening there is that the death rate is affected due to disease control. More on that in just a second. So we'll get control of disease increasing, but we'll also get personal sanitation and clean water. All right, those things help prevent disease spread as well. So that'll drop the death rate somewhat. The birth rate stays high because traditionally families are still relying on the work of their members in order to provide for food and other needs that they have, economic needs. So it was quite common, as we mentioned earlier on, to have large families where the children helped with the work on farms or would serve as caregivers for parents as parents got older. So it was common to have not many children, but 5, 6, 7, 8 children in a family. Additionally, in some cases, religion might have frowned upon birth control or contraception, which would seeing it as something that's unnatural, and therefore that would lead people to probably, or a greater number of people to probably not use contraception as much. So therefore there'd be fewer births being prevented, and therefore an increase in your population. So during stage 2, early expanding, we see population of the world doubling from 1 billion to 2 billion in a little over 100 years. Okay, from 1804 roughly to 1927. Okay, so if we look at it this way, it took all of human history up to around about the year 1800 to get to 1 billion people. And then in less than 100 years, or a little over 100 years, I should say, the population doubles. That's incredible. So there's some major things going on with the prevention of disease here and death. So we look at two major contributions to this, just as an example. There are others, but just to get the point here. One is in disease control. Edward Jenner was quite famous, or has become quite famous for his contribution to the smallpox issue, which plagued humanity for thousands of years. So he was a doctor in England in the late 1700s, and he wanted to figure out one of the mysteries surrounding smallpox. He noted that in his area around where he was working in 1788, there was a smallpox epidemic that broke out, and he was the doctor in the local area, and he noticed that a lot of people were getting sick and dying of smallpox, but the people who worked in particular on cattle farms, or those who, or milkmaids, for example, who worked in close quarters with cattle, were not the ones who were getting smallpox and dying. It's almost as if they were excluded from the epidemic somehow, and he wanted to find out why. He theorized that cowpox, which was another disease that was somewhat similar to smallpox, but far less serious, and much more easy to recover from. He theorized that cowpox was these people who worked around cattle were exposed to cowpox, and it's somehow, because it was similar but less serious, provided them some kind of protection. And so through a series of very, scientific experiments, I guess you might say, but also human testing, he would inject. He started with a small boy, injected a smallpox into that boy who had already been exposed to cowpox, and he discovered that the boy did not. 2 months later, when he was exposed to smallpox, he did not get it because he had already been exposed to cowpox. And so he continued with that type of testing, and more or less discovered that cowpox provides protection for smallpox. And so this is the basic idea behind modern vaccinations, right? How we can use a mild version of a disease or a virus to prevent more serious versions. And so really what Edward Jenner did in discovering this connection between cowpox and smallpox was ultimately, over subsequent years, through himself and many other people working through vaccinations and so on, saved the lives of millions of people who down the road would never get smallpox. And so that's certainly a great example of how technology and scientific understanding on the part of humans can help control disease or reduce the risks of disease. So therefore, many, many people would remain alive and live longer due to not contracting smallpox. So that's an example of one of the major medical innovations at the time that helped bring that blue line on our graph, that death rate line, down in stage 2. Germ theory was another major contribution by Dr. Semmelweis in the 1840s. Before this, we did not know that diseases could be spread by organisms that were so small you couldn't see them. And so even things like the simple practice of doctors washing their hands before they see a patient and then after they see that patient was a brand new idea. Okay, people didn't know that there was germs or infectants on a doctor's hands that could be transferred from one patient to another. And so it's during the Industrial Revolution that we start to see some of this understanding develop. We get Dr. Ignaz Semmelweis, who he worked as a doctor in a maternity hospital in Vienna. And what he noticed is that many of the mothers who were coming in to give birth were actually getting very, very sick and dying. And through much stress on his part and observation and questioning of what was actually happening in the situation, he came to the conclusion that whenever hands were washed and basic sanitation was followed, these women tended not to contract as much disease and therefore did not die. So we started to advocate for hand washing on the part of doctors and medical professionals. And this, in and of itself, was a massive development for medical technology and medical understanding. So it's the development of germ theory is what we're seeing. And that contributes to reduction in death in not just maternity hospitals, but any hospitals, any doctor-patient scenario where cleanliness is important. We know that today, but these were new ideas in the 1800s. Okay. So let's move on to stage 3. We get late expanding. So in the late expanding period, we know we have a low death rate already, okay, because medical advancements in stage 2 have reduced the death rate in the country, but we start to see that the birth rate starts to decline as well. And it won't level off with the death rate just yet, but it'll start to slow the population growth. Okay, and if we look at our graph over on the side here, if we look at what was happening with Sweden, this is characteristic of Sweden up to about 1980, in the 90 years from 1890 to 1980. So we can see here that the death rate continues to decline somewhat, okay, until it falls down to around about 10 deaths per 1,000 people. The birth rate at the beginning of this stage, close to 1900, was almost 30 births per 1,000 people. Okay, so population is increasing quite a bit here, but we can see that the birth rate declines. And by the time we get to 1980, there's still a bit of a difference, but it's much, much lower than what it existed before. So the birth rate or the population growth rate is going to be much lower here at the end of this stage. So stage 3, late expanding, represents more economically developed countries during most of the 20th century. So this is the time period where we see that industrialized nations, countries that have already been progressing in terms of their economies, but also their technologies and education and scientific discovery and so on, they start to see this pattern happening with a subsequent decline in birth rates. So better medicine and healthcare mean low infant mortality. And we might say, well, okay, that's going to mean fewer people dying. So won't that increase the birth rate? But the issue here is that throughout history, as we said, families tended to have large numbers of children, partly with the expectation that it was very common for families to lose children at a young age due to disease or malnutrition or whatever it might be. So what this would do, better medication and healthcare, would mean that it would become more common for children to live longer. Therefore, families who needed to support family farms would not necessarily have to have as many kids in an attempt to maintain their family. So their birth rates can go down if their children are living longer. Okay. So that's one point here. We get more people started to move to cities to work in factories. So even the nature of work starts to change, right? So people move from rural areas into more urban areas because increases in food production in rural areas due to better technology during the Industrial Revolution is going to mean that there's more food available for more people. So therefore, fewer people even need to work on farms, okay, in the first place. So that'll contribute to fewer births, but it'll also contribute to people moving to places where larger numbers of children are not required to support families. Not in the same way, certainly. And finally, we get more women begin working, and therefore you get double incomes in families, which could mean many families become better off. So this whole point of women beginning to work is vital. When women start to work, they probably have less time to work at home as mothers, and will probably be inclined to have fewer children as a result of that. But also, having larger income will mean that certainly you don't need to have a lot of children now to help look out for your security into old age, because you're more able to do that yourself, and fewer children in any event would be able to help contribute due to higher incomes. So we get a decrease in the birth rate occurring. So population grows slow but reaches 4 billion by 1974. So even though population is still increasing, it's starting to slow down how quickly it's increasing. So let's move into our fourth stage. We get stage 4, low stationary. And this is at the end of the formal demographic transition model. We're looking at a small period here in Sweden's history, much more recent. So at this point, the death rate we know is very low. And the birth rate is also now very low because it's continued to decline due to those factors we just mentioned in the last slide. So this stage represents more economically developed countries at the end of the 20th century. Okay, so after 1980, getting into 1990s and even the beginning of the 2000s. Right, so birth and death rates are low and they're more or less equal. Right, so that's stationary, stable population scenario. Highly urbanized lifestyle. A lot of people live in cities now. If we look at Canada, for example, if we go way back into early Canadian history, statistically, it was we were looking at probably about 20% of people in Canada living in cities and 80% living in rural areas. Just as we said, dealing with resource-based economies, farming, agriculture, and that type of lifestyle. Today, we see a dramatic shift where it's almost the opposite now. We get almost 80% of the Canadian population lives in urban areas or cities. So that's a dramatic shift. And the same types of activities that would have been done in by these people in rural areas aren't being done anymore. Most people work in the service sector now, but also in industries, factories, and so on. So economically, there's significant changes. We also get smaller families due to lower infant mortality, right? So continually we get better and better medical care, medical understanding, technology, procedures, and so on, which, and, to go along with that, better nutrition, we get infant mortality going down further. Um, so there's less of a need, again, to continually have more children, because the chances are most of your children will survive into adulthood. Um, and the trend of women joining the workforce continues, and is at a significant point today. And what we find many uh, women tend to do now is to delay having families until they're a little older, in favor of education and careers. So they want to further their um, eventual careers, rather than choose to have families early and stay at home. So a difference, for example, might be that uh, it was much more common many, many years ago for uh, women to marry at a young age, sometimes maybe 17, 18, 20 years old. Um, and in that situation, they have many years of married life with which to have children. Okay. But nowadays, women are tending to delay having families. So some women are, rather than being 20, they might be 30, even 40 now before, or even older before having families. So that's going to result in, over the course of their lifetime, fewer kids that they're going to have. Um, so again, that birth rate comes down even further. And now it's more or less level with the death rate, which will give us a rate of natural increase of nearly zero. Okay, so the population is stationary or stable once again. Human population reached 7 billion by 2013. Okay, so the population continued to increase, but again, it's still slowing down globally. Uh, and the growth rate globally has continued to decline, as we just said. So many developed countries, MEDC countries, are in stage 4 now. Um, Others, with lesser level of economic development, tend to be in stage 3. Many countries that have significant population issues are actually in stage 3, but we'll look at that as we move further along. So here we go. If we look at Sweden's numbers through the course of its history, you can see what's happened with its birth rates and death rates here. This is just taking each of the graphs that we've looked at in this section and piecing them together. And so you can see up here, birth and death rates higher, anywhere between 30 and 40 on average, until down here, closer to the present day, where it's more like 10, 11, 12 for the birth rate and death rate. So that's a significant change. Okay, so this is a pattern that we find happens to many countries as they continue to develop. So this process for Sweden took many years. They had to go through a period of industrialization, and with it, social and economic changes that would encourage new technological developments, new scientific understanding, and over time, those understandings and new technologies will contribute to, at the end of the day, lower birth rates and lower death rates. Okay? There are other countries today who are not in the same situation, who had not continued all the way to stage 4. And some are still in stage 3. Some progressed through these stages faster than Sweden did after the fact. because new technologies became available much more quickly. So, a country, for example, who begins this demographic process or shifting from stage one to stage two later in the 1900s here, or starting around about 1900, has the advantage of all the technological developments that occurred earlier that Sweden and other countries had to incorporate gradually. They can sort of, that other country can now sort of incorporate those things quicker, and therefore you can almost see a decrease in the death rate and the birth rate at a faster rate overall by comparison. But that's just a difference, one of the differences we highlight between countries and how this process might work. It's it's a model. It doesn't fit every single country on the planet, um, but more or less it's a general pattern that's followed by many countries. So again, very quick summary. You have stage one, where the birth rates and death rates are both high, uh, resulting in a stationary population. Then, as we move into stage two, um, control of disease and new sanitation um, starts to decrease the death rate, um, but the birth rate still remains high because the basic economy and family structure and social structure still exists. So you get an increase in population as a result of low deaths and birth rates remaining high. When we get to stage three, we see that the birth rates start to decline as well, um, partly due to new technology and access to birth control and things like that. But a very significant one is the change of life for women, where women focus on careers and start to shift into the workforce at a larger number and therefore delay having families until they're older and therefore having fewer children. And then we shift into stage four, where the birth rate and death rate is more or less um, equal, creating a stable or a stationary population. So therefore, the population is not growing very quickly at all in these countries. And again, this is a result of continued um, access to education and careers for women, further medical developments, better nutrition, uh, low infant mortality, and the survival of children. So these are the main things that fuel demographic transition. Uh, in the next in the next video, we'll take a brief look at population pyramids, how they link to demographic transition, and how they're useful in uh, profiling populations and the issues that those populations may have.